Hello and welcome to Easy Projects. So I've been thinking about building my own 3D printer for quite some time. And now I finally took the first step and actually ordered the parts. So let's take a look at what I'm planning to build. The Flashforge Creator X is serving me pretty well, but the build plate is only 15 by around 25 centimeters, give or take. And it can also build objects 15 centimeters tall or thereabouts. I have already had a few things I couldn't print on this because it wouldn't fit the dimensions of the build plate. So I'm thinking of building something a little bit bigger. Originally I wanted to go with the XY movement that the Ultimaker 3D printers use. They don't have these two going in the X direction, they have a single in this direction and a single one in the Y direction as well. And they are also rotating the linear rails for the movement of the other axis. So they will have the belt pulley fixed to this one, and when they rotate it they can move this back and forth. But to do that they use bronze bushings instead of these linear bearings. I was not sure if these linear bearings could rotate around the axle here, but they can't, so I can't do that unless I buy some bushings. And the reason why I went for these is they're actually a lot cheaper, even though they have bolts and stuff inside. The bronze bushings are just solid, of course. So to wrap up the story, I might have to go with a simpler design like this one, where we just have one axis moving on the other axis. The advantage of the other one, and you can go look up the Ultimaker printer if you want to see, the advantage is that the stepper motors and these fairly heavy axles does not have to be on the actual print head, so it is a lot lighter and it can print faster. Yeah, well, they have two axles as well, but the other one is in the other direction. And it just seems a lot lighter. And also they don't have the stepper motors for the extruder mounted on this slider there. They just have a tube going and the extruder sits on the back of the machine. This should of course be more precise in theory when you have the extruder just next to the nozzle, but looking at the prints from the Ultimaker, it doesn't look like it's that important. So I bought my linear rails at 50 centimeters each, and I'm hoping to get around 35 to 40 centimeters of print head travel, most likely 35, but we'll have to see. I also ordered one of these trapezial screws in 1/2 meter as well, and I got a total of 8 of these, of course. And these linear bearings will be sliding on the axles. And I got a whole box for almost nothing. You won't believe how cheap these are. I think it was like 3 of these for $1 or something. Some 8mm pulleys for the axles. I might have to change these if I go with the other design that I mentioned, but we'll see. I bought the end stops pre-mounted on a little PCB with cables and everything, and with screw holes, because there's no reason not to really. They are almost the same price as just the micro switch. And we of course need some belts. I think these are called T2 belts, and the pulleys fit the stepper motors, so these will be for the linear axles, if I'm gonna use them. I don't know. A couple of bearings would come in handy, so bought a couple of tubes of those. Yeah, so this should be all the mechanical parts, and I should have enough linear rails no matter if I choose the Megabots approach or the Ultimaker's approach to make the XY movement. If I go with Megabots approach, though, I will be using a hard-plated steel rod just to keep timing between the two sides of the printer. Maybe a bit of an overkill, but hey, I got them anyway, so might as well use them. Well, of course we need some electronics as well, and for that I am going with the RAMS 1.4, which is used by the RepRap 3D printers. This RAMS is a pretty old invention, and there are some more modern things out there, but this one is using a standard Arduino Mega, and it just plugs right in. And also the stepper motor drivers can be replaced if you fry them or if you want to go with something else. But apart from that, it's mostly just a whole bunch of connections. There's nothing on this really. It's all done by the Arduino. And I bought a graphical LCD display just because I think it looks nicer. It has no actual advantage, I don't think. And this resistor on a wire here is just to prevent it from pitching over the temperatures either too high or too low. I am going to use an open source software to begin with, because all this writing software takes a lot of time and a lot of trial and error, and I just want to get it working. And the software is pretty comprehensive anyway, so I might just change a few things if anything. I might try to make my own at a later point, but yeah, not really interested that much in writing the software, so we will see if this can do. I think this software is called Marlin, but I forget the version of it, but you can look it up if you want. It's just the newest. We will need some thermistors, and they have to be the high temperature type, of course, so it's all glass and metal, and it's welded and no soldering. And I almost forgot the nozzle here. It's a standard 0.4mm, and the rest of the extruder I will be making myself somehow. I haven't thought about that yet. Yeah, I don't know if I forgot to show anything, but I have some smaller bearings for the extruder, of course, and we will take the rest as we go. We need to put this in some kind of enclosure, of course, and for that I'm using some hard plywood. I want the printer to be as rock solid as possible, so I chose to use 18mm plywood, and it's probably enough. It's 60 by 80 centimeters pre-cut, and it's pretty square, so at least on the width I don't have to cut it any further. I think 70 centimeters in the height would do, but I can always cut the plates when I figure that out. All the rest of the brackets and hardware and stuff like that, I'll have to make that myself as I go, but I haven't completely figured it out yet, so I'll make a few drawings and see what I can come up with, and we will probably take that in the next video. I will also have to come up with a method to get all the linear rails parallel and square, otherwise it won't be a very good printer. But I'm sure I'll figure that out, so I think that was pretty much all of the materials. Well, of course I bought all this stuff from China, and it came in at less than $250. But another $100 for the wood here in Denmark. Pretty expensive, but hey, only a third of the price of the printer. I could have gotten the wood a little bit cheaper if I bought a full plate in 244 by 120 centimeters, but I have no tools for cutting it square and straight, so I thought it was better just to buy these so I can use at least the width as it is. And also the bigger plate seems to warp a little bit more, but maybe you can find some that don't. So I'm sorry if this video was a little bit boring just showing off all the materials, but we will kinda need to know what we have to deal with in the next video, where we will try to figure out how to mount all this stuff inside the enclosure and make sure these get parallel and square on each other. And we will have to make some brackets to fill out the last 5 centimeters in each end of the linear rails. Or to be accurate, it would be 5 centimeters minus half of the thickness of the plate, but you get the idea. I hope you find this project interesting. At least I'm looking forward to getting started on it, and not least getting it finished so I can start using it. If you like this video and the project, please give it a thumbs up, and thanks for watching this video. I will see you in the next one. See you.